So let's open up Nime. And normally when we would do these, we'd all be sitting in a room together, maybe 20 people, and we'd say, hey, we're going to start group 1 exercise, and you guys would break up into groups of 2 or 3 and work on that together. But COVID has ruined the way that we do Learnathons. So now we have to do a little different approach. And instead, what we'll do is I'll actually open up the exercise and I'll work on it in front of you and just kind of give you a live demo and do it for you. Hopefully you have Nime installed and you have the exercise loaded up so that you can follow along with me and do it as I go. And then as we have questions and stuff along the way, you guys can just speak up and let me know. I'm happy to stop and answer questions. But this will be a little different than how we normally do it. Normally we have you kind of load up Nime and beat your head on the table in frustration, because that's the best way to learn how to use a tool like this, right, is to use it in anger. But we can't do that today, so the next best thing is I can show you in detail how this stuff is supposed to work. So if we open up Nime over here, if you've loaded the Learnathon 2020 archive and go to group 1, you'll see this group 1 data access and data manipulation. So if I double click on this here, then I'm opening up my workflow, and what the workflow consists of are some instructions here, exactly what it is we're intended to do, and it consists further of what are called meta nodes. So these meta nodes are these gray boxes here, and we can actually double click to go inside the meta nodes and see additional instructions about what we're supposed to do at each step. So we'll actually follow this all the way down the line for each of these sub-steps, beginning with reading the data in and ending up with partitioning our data. So if we start on part 1, the data access, I guess this is part 0 really, maybe. No, part 1. If I double click on that, now I'm inside the meta node. And again, I'll try and blow this up and make it a little more visible since my screen is big. Here are our instructions, and then we just kind of have this blank area, this yellow box that we want to work in. So what we can do is read the airline dataset.table available in the data folder. So what you will see here is, in addition to the actual workflow itself, you'll see the data folder here. And then there's an input folder and an output folder. So the instructions say, let's look in data 1_input group 1. And we're going to find an airline dataset.table and this GHCN daily source Excel file. So to read this data, this is actually pretty straightforward. It's basically what I did in the demo. We're going to drag and drop from the Nime Explorer into our workflow. So this first one is a table file. It has a table extension. So Nime knows that it needs a table reader to process this file. What is a .table file? Well, it's basically just Nime's proprietary binary representation of a data set. And the nice thing about it is when you read it in, if I double click on the node to configure it, I don't have to provide anything except the path to the file. In fact, when I execute this node and look at the results, you'll see that because it's a Nime table file, it already contains all of the different names for the columns, all of the different column types, all of that is in there inherently. It doesn't have to guess about any of it. Also, Nime reads tables really fast compared to like CSVs where it has to do a lot of parsing and stuff. So that's easy to read in. We drag it in and drop it. And then we also have the GHCN daily source.xls. Since this is a .xls file, Nime is going to say, aha, I'm going to use the Excel reader to handle that. Now, we do have to do a little bit of configuration on this guy. When we double click on it, we see that, for example, if I go to the bottom and look at my preview, all of my columns have names like call 0, call 1, call 2, and it looks like the first row in my data set is actually what the column names should be. So if I go up here about a third from the top, there's this option that the table contains column names in row number 1. I can check that box. And then I get a little warning message in my preview that says, my preview table is out of sync with my current settings. Please click refresh. So I'll click the refresh button. And now I have appropriately named column headers for each one of these guys. Now, not everything is still right here. I can see some examples like, clearly I have some numeric data that's been misclassified as a string, but that's stuff that we can fix later. For the time being, I just want to make sure that the data gets into Nime with the proper headers. So I've done that. There are a bunch of other changes I could make here. but they don't really apply in this case. So I can click OK, click Execute. And for this first thing that we have listed, or this first task, this is really all we have to do is read in these two sets of data. The last thing is I want to actually drag and connect this table reader to my top output port for my meta node, and the same for the Excel reader. So this is just making sure that my data can make it out of the meta node back to the top level of the workflow. So that's all we have to do here. I can close this tab now. And you can see because I executed everything and connected it, now this meta node has changed from this yellow clock looking icon to a green check. So we've done everything we need to do in data access. So question from Mark in the chat: how do you upload your own data to the Nime Explorer? Usually what I do is I would just do that within my own, I can go into my file explorer in Windows in this case, and then I need to find my Nime workspace. So mine happens to be under Users, Scott, and I think Online Summit is my current workspace. And then I can actually go and put data out here within my workspace, and even inside additional workflows themselves if I want to. But that's what I would generally do. I would copy files to my workspace, and then you'll see it show up within the Nime Explorer. Okay, let's move on to feature engineering part 1. So this is where we're actually going to start looking at the data and cleaning it up a little bit. So we're going to double click on the meta node to go inside. Again, I'll blow this up and zoom a little bit. So first thing we want to do is convert the date columns in both data sets from the data type string to a native date and time format. So we're going to use the string to date and time node to do it. So I'm going to go to my node repository, find the string to date and time. And I'm going to need 2 of these because I have date and time formats that are actually different in my 2 data sets. So I'm going to drag in 2 of those nodes. Go ahead and connect from my leading data ports here. And so let's configure the first one. I'm going to double click on the string to date and time node. And you can see by default, all of my strings that it knows of in my current data set are on the right-hand side in the include box. That's not actually right. Not all of these are dates, right? In fact, only one of these do I care about doing a conversion on, the field called date. So I'm going to highlight all of these different fields here and click the left arrow and move them over to my exclude box. So anything that's in the red exclude box is not going to be dealt with. Anything in the green box, we're going to perform a transformation on. Now I can see here, this is some field called date. And if I go down and look, I have some options that I need to change here. So do I want to convert this to a date, a time, or a date and time? In this case, it's just a date. And now I can see the contents of my first cell look like this, 01-01-2007. I can click this button to guess the data type and format. And what Nime is doing here, it looks at that and it says, oh, okay, I think I know what that is. It's, month, day, year format. The capitalization here is actually important. Capital N represents a month and lowercase m represents a minute. So you have to get the capitalization right. And if you're not sure what the syntax is here, you can actually look in the description pane on the right-hand side. It'll give you some examples of what the date format conversion string should look like. But Nime has guessed it for me already. If Nime wasn't able to guess it properly, then I actually could just type it in here as well. That would work just fine. So if I go ahead and click OK here and execute the node, I get an error message. What Nime says is, if I look down at my console, it says it failed to parse the date in some row. 13-01-2007 could not be parsed. Well, that's weird. Why is that? It turns out that this is not month, day, year format. This is actually European day, month, year format. So I do need to go in and change this manually and not let Nime guess at it. I can actually make some changes like that. Just type it into the date format field. Now when I execute this, things should run properly. So you can't always assume that Nime is going to guess properly. It does its best, and generally it does a good job, but sometimes it's not correct, especially if you have non-standard formats like this one is. Now for the other string to date and time, if we look at that, again, a bunch of fields here that I know are not dates. So I'm going to pick only the one that is my date and make sure that it's in the green box. This cell format is different If I look at the content of the first cell, I don't have any hyphens in it anymore, and it looks like the ordering is different. So again, I'll guess the data type and format. Nime says, okay, this looks like year, month, day, no hyphens. So I'm going to click OK and execute. Did Nime get it right this time? Yes, it did. So when we want to see if we were actually converting properly from string to date and time, I can open up the table and look. Before, let's make this bigger, I had an S for a string up here. Now I have a date with a calendar icon by it. And that actually is important that it's now classified as a date time object, because I could do things to this field like extract, day of the week from it. Or I could calculate the duration between two different date fields and do some other things that I couldn't do if this was just a regular string. Plus, it also helps us that later we're going to join these two fields together. We can now join them on a common format, date and time, which is really the whole point of doing this bit. Before I move on with some of the other nodes in this section, there's a question. John asks, can I connect Nime to Microsoft SharePoint? Yes, in our most recent release, we introduced the SharePoint online connector. So you can call up SharePoint, enter your information for your SharePoint site, and then pull Excel files off of it or whatever you need to do. So that's still in our labs extension. It's because it's an active development, but it works pretty well enough to where we recommend that people can use it. Okay, let's keep going with the exercise here. After we have converted things from string to date and time, now we're going to do a little bit of filtering. First of all, we want to keep only records in the airline data set with the origin equals ORD, meaning from Chicago O'Hare. So we're going to use the row filter node to do it. So I can go down to my node repository, type in row filter, drag it in, connect it together. And now to keep only those records that match, I'm going to open the configuration dialog. I'm going to test on the origin field. So I'll scroll up to that. I'm going to match on ORD. And then I'm going to include rows that match ORD. So I could exclude, do the inverse operation, but here I want it to match. So if I click OK and execute and look now at the results, I should see, if I go over to my destination field, only ORD, and it looks like that's the case. Okay. Turns out that, oh yeah, and the other way that you can look at this too is in the original data set, we had 621,000 rows roughly. Now, after we filter down to Chicago, we only have about 31,000 rows. So we filtered out quite a lot, right? 95% of the data roughly. Now let's do something else. Let's remove the canceled flights. So we're going to use another row filter node to do that. We use another row filter node because we're doing a test on a different column here. So the other column we're testing on is called canceled, not cancellation code, but canceled. So if the canceled is equal to 1, then we want to exclude it. So get rid of that. If a flight's been canceled, then we don't want it to have any effect on departure delay, right? That doesn't make sense. So we just want to get rid of these. So click OK and get rid of those guys. Now, let's apply our binning operation. You remember before in the introductory slide, I said, if something has a delay greater than 15 minutes, we want to classify it as a delay. And if it's not, then we'll say it's no delay. So we have a numeric value for the delay currently that we want to change essentially into a binary operation. So let's use the rule engine node as suggested in the instructions to do that. Now the rule engine node has a little bit of its own syntax here. Goes like this. So I need to build out an expression in the bottom that's going to assign an appropriate string to each of the fields. So what I can do, I could just manually type this, but sometimes it's easy to kind of click to assemble an expression like this. So I'm going to go find the dep delay column. Where is that? So it's an integer in my column list. I can double click. And when I double click, you can see that I've added the dep delay to my expression. It put little dollar signs around it because that's to indicate that there's a column there. So the dep delay, if it is greater than 15, so I've just typed that in, then I use a special arrow character, which is the equal sign and the greater than sign. So this basically is an if-then statement. If the thing on the left-hand side of the arrow is true, then I'm going to assign it a value of delay. And in fact, I'm going to create a new column here. I currently have something called dep delay, which has a numeric value. Now I'm going to make a column called departure delay that's going to contain my binary string indicator. So if dep delay is greater than 15, we're going to call this a delay. What about everything else? Well, there's a special operator in the rule engine node called the true operator. What this says is basically, if this is anything else, then we're going to classify it as no delay. So this makes sure, because we phrased it this way with this other kind of catch-all operator, that we're going to get one of two classifications for every single observation in our data set. So let's see how that works when we click OK, execute, and look at the results. We now have this new field tacked on to the end of our data set called departure delay, which I chose for it to be, and it's either no delay or delay. So this is the thing that we're going to use as our target variable when we get to building the model, which we won't in group 1, but if you're doing group 2, this is what you would use for your target in the model. Okay, this is all we needed to do for feature engineering part 1. So I guess we also need to connect this to the output ports of this meta node to make sure it gets passed on to the next meta node. Okay, any other questions about this bit? I think so far this is pretty straightforward. The syntax, some people get tripped up on the syntax for the rule engine node, which I understand it's a little bit weird, but hopefully it's not too off-putting or off base. Okay, let's move on to feature engineering part 2. So now we want to do some additional joining and cleaning of our data. So the first thing we're going to do is take those 2 date fields that we created in the previous step, and we're going to use that to join them together. And to do it, we'll use the joiner node. So if I go search for the joiner node and find it and drag it in, you can see it has 2 input ports here. So we're going to connect both our airline and our meteorological data into the joiner. And the instructions say use the date column as the joining columns, use an inner join. So if you're used to, joining in MySQL, for example, this will probably seem familiar to you. We have 4 different joins that we can do, from most restrictive to least restrictive. So the inner join, I won't go through what all of these are. If you don't know, don't worry about it. Just know that you need to pick inner join for this particular operation. And we also have to pick the fields we want to join on. So we can click on the add matching criterion here, and then click on, not the row ID, but we want to scroll down and find the date, and then the date from the other. So the left table, this is our airline data set, and the right table is the Met data. Question, what if the dates in a specific column have different formats? How are we going to clean it or fix it? Well, they actually did. In the previous portion here, this is where we fixed that. Using the string to date and time node, these date formats were actually different. Like if you look at the content of the first cell, it looked like this. It had the hyphens, and the month, date, and year were in a different order compared to this guy, where it didn't have hyphens and it led with the year. But once we've converted those from strings to a Nime date and time, now they have the same format by necessity. And that's why we can in turn be confident that we can join on them, because we know that they are now the same format. Does that make sense? Usually if you have any cleaning to do on dates, well, not usually, you might, if the formats are really weird and have some strange things going on, you might have to do some cleaning even prior to the conversion to string and date time. That's possible. So hopefully I answered your question. So we selected here inner join, and then we joined on date. Now in this column selection, by default, Nime is going to take every column from the left table and every column from the right table and include all of them. If for some reason there were different fields here that you didn't care about, that you wanted to get rid of, you could uncheck the always include all columns box and then just move them over to the exclude and tidy up your table a little bit. In this case, I'm actually fine with keeping all of the variables in both tables. That's fine with me. So I'm going to click execute, look at my results. Now I have About 30,000 different rows and 65 columns. Now, the next thing we want to do here is remove columns that contain more than 80% missing value. So if we have a column that's mostly missing data, that's not something that's going to be helpful for us in building a predictive model, right? It's probably just noise. And so what we'd like to do is remove columns like that so that when it does come time to run our model, the model probably is going to run faster because it has less junk to deal with. So we can use what's called the missing value column filter node to do that. We'll go down here to missing value column filter in the node repository. And this one's an easy one to configure because it says we're gonna look at all of our different fields. We'll look at all of them, and we're just gonna set the missing value threshold. Right now it's set to 90. I'm gonna change that and set it to 80. And if any of those fields have more than 80% missing values, those columns are just gonna be removed. So we've gone from 65 columns now down to 50. So 15 columns removed just by this one node and looking at fields that mostly didn't have much information in them. So that's helpful. Something else we want to do too to clean things up is remove rows where the value of depth delay is missing. So there's a couple of ways we could do this. We could use the row filter or the missing value node. I'm going to use the row filter to do this because we're going to use missing value here in a second. And I want to show you how both of them can accomplish that. So for the row filter, we're saying if the depth delay is missing, so I need to go find depth delay. That was our numeric representation of delay here, not departure delay. And what we're going to say is if it's missing, exclude it. So instead of using the pattern match like I did before, I'm going to take my radio button and click on only missing values match. So if depth delay is missing, exclude. Okay. So now when I click OK and execute, if there were any rows with depth delay missing, they should be gone. It turns out this is a little bit of a trick exercise. There weren't any. So the number of rows remains unchanged. But I think it's useful to demonstrate how you can do missing value filtering using the row filter node. Now, in most cases, to get rid of missing values, you're going to probably just use the missing value node. So let's use that next. Because what we're saying here is we're going to do a few things. We're going to set missing values in the string columns to some fixed value. We're going to call it unknown. We're also going to set missing values in integer columns to the most frequent value in that column. And then we'll remove rows that have missing values for date and time. We can do all of those things, all of those three things in a single missing value node. So if I look at the configuration of this node, what did it say? For string, if we have a missing value, we're going to say use a fixed value of unknown. And so I can just type it into the box. For numbers that are missing, and more specifically integers that are missing, we're going to select the most frequent value in the column. So I can go down here and select most frequent value. I could do other stuff too, right? I could pick the median or the average or the minimum or the most recent, or there's all different ways you could do imputation depending on what it is you're trying to do. We're going to pick most frequent value here. And then finally, for the date fields, if we have any date fields that are missing completely, then we're going to remove those. Now you'll see this one has a star by it, and that says here at the bottom, the options marked with an asterisk will result in non-standard PMML. That just means that the PMML model that's used to represent missing values that's generated, it can't deal with removing rows appropriately. In our case, this doesn't matter because we're not going to be using this missing value model for anything else. We're just pulling data out of the data set, which is what we want to do. So let me click OK here and execute. You see I get another little warning message here about the PMML. It's going to gripe about that, but that's okay. I'm not necessarily worried about that. So this is going to change any of our, if we had red question marks in our data set anywhere. Let me see if I can find some of those. Oh, there should be on the right-hand side. You see in this column, WTO1, WT16, these are meteorological events. They're missing, and Nime represents missing values with a red question mark. And so what we're doing is we're going and replacing a bunch of these red question marks in other fields that happen much more intermittently with, um, like we said, either constant values or the most frequent value, depending on what it is. Now, I should say we did this by type of variable. We applied these strategies very broadly. Oh, whoops, we're getting a message. The rooms will close, but I will reassign. Okay, we may have a short break here for a second. Okay, well, it looks like you guys are still with me. Maybe the clock just goes down and nothing happens. Okay, good. I'm going to keep going. So we can apply these missing strategies broadly on a variable type basis, but often that's too broad, right? We can be more specific. And if I go into the column settings, for example, if I had a very specific way in which I wanted to handle missings in, I don't know, WTO1, I could click on WTO1 and then say, for this one, for whatever reason, I want to set it to the next value. Why would I do that? In a time series context, sometimes maybe it makes sense to do it that way. The point I want to make here is whatever choices I make on an individual column basis will override my type-based defaults. So you can be as general as you need to be. You can be more specific if you want to drill down, and you apply missing value strategies in exactly the way you want to so that you get good implementation. So just wanted you to be aware of that. But as it is, this is fine. Okay, I've got a chat message from Mark. Don't worry, I'll look into it later. Okay, yeah, sorry you're having trouble. Maybe we can take some time at the end and look at that one. Okay, after we have done our missing value imputation, we wanted to do some binning. So for binning, we're going to use the numeric value, or the numeric binner node. So let's go find that in the repository. Drag it in. So in this case, we have distances of flights, right, from Chicago to wherever. So we want to bin these in particular ways. We'll say it's a short flight if it's less than 1,000 miles, a medium flight if it's between 1,000 and 2,000 miles, and a long flight greater than 2,000 miles. So maybe that's international flights, right? For our model's sake, we don't want to predict using the linear value of the length of the trip. Instead, we'll use these bins. So to assign the bins, we can use the numeric binner. And I can go in and say, okay, flight distance is the thing that I care about. Where is, not flight number, it's just distance. Okay, I want 3 bins, so I'm going to click the add button 3 times. 1, 2, 3, now I have 3 bins. We're going to say less than 1,000, so we'll go from negative infinity to 1,000. And instead of calling it bin 1, we'll call it short. Then next up, I'm going to call this bin medium, and it will be from 1,000 to 2,000. And then my final one will be long, and it's already been set from 2,000 to infinity. So that's all I had to do there. And I have an option here. I can either overwrite my existing field, my distance field, with these strings, or I could click this box to append a completely new column so that I would retain my numeric distances, but also have the bin as well. In this case, I'll just overwrite them because that's fine. So if I click OK, look at the results after I execute, and go and find my distance, there it is. So what are my distances from Chicago O'Hare? I suspect most of them are going to be pretty short. We see some mediums in there, a very occasional long. I know there's a flight to Anchorage in there that's a long flight. Yeah. So that's how we bend those out. And now the last thing we want to do here for our initial cleanup stage is remove columns only containing constant values, so we can use the constant value column filter. We before used the missing value column filter to get rid of fields that just didn't have very much information in it. This one is going to get rid of fields that are have constant information. So if I have a field that consists of only, the number 1, for example, that isn't going to help me predict anything in my model. I'd also like to get rid of that. So I can use the constant value column filter, to get rid of those guys. And in fact, I'm not even going to do any real configuration of it. I'm just going to say remove all constant value columns. So when I do that, I've gone from 50 columns down to another 43. So 7 of my columns in this data set were constant. So more garbage that we've gotten rid of just by using a single node. And then again, we'll connect to the meta node there. Okay, so we're a little over halfway through here. How are we doing on time? Oh, good. We're about 30 minutes in. So we should have time to do some of the outlier detection at least. Another message in the chat. Oh, okay, good, Mark. It looks like you figured it out. Yep, used periods instead of hyphens in the string to date and time. Good. Glad you got it squared away. Okay, so next on the outlier detection section, now that we have cleaned up some of kind of the obvious, missing values in our data, we've joined together 2 data sets based on a common date field. Now we're going to look at things from an outlier perspective. So there are still values in my data set. Just because they're not missing doesn't mean they're any good, right? We could have values that are way outside what we would normally expect. And so there's some ways that we can identify that. Let me blow this up again. So let's say, for example, that we wanted to calculate outliers based on this particular formula. So there's a formula here that says if the mean of the arrival delay plus 10 times the standard deviation of the arrival delay, if our arrival delay exceeds that, then we're going to say that's an outlier. So to figure out whether something is an outlier or not by doing it manually like that, we can use a couple of different nodes, the math formula and the rule-based row filter node. So let's start with the math formula because this is one we haven't seen yet. The math formula basically just allows us to do calculations on our data. So what are we saying here? We're saying we want to calculate the mean of the arrival delay and 10 times the standard deviation of the arrival delay. So within the math formula node, again, we're going to build some expression. Let's call this, I'm going to create a new field. Instead of calling it my column, I'm going to call it my stats, for example. And then I need to build this expression, the mean of the arrival delay. So what I could do is I have functions here in the middle that I can double click. You can see, for example, I have a column mean. So if I double click on column mean, it's going to put this down here and put my cursor between the parentheses, which is nice. So what I want the mean of, I want the mean of the arrival delay. So I can go over here and double click on arrival delay, and it'll put that in there again with the little dollar signs to indicate that this is a column. So the mean of the arrival delay plus, I can manually type this in, 10 times the standard deviation. So call standard deviation, again, of the arrival delay. So that's a thing that I'm calculating here, this value. If my arrival delay is more than this, I'm going to say that it's an outlier. So I'm going to click OK and execute. And it's just giving me this new field called my stats, which turns out to be about 477 minutes. So if the arrival delay is greater than that, then that's an outlier. That's a really long delay, which seems obvious because 477 minutes is like 7.5 hours, right? I'd say that's a long delay. So to actually apply that, we can use the rule-based row filter node. So I have to type that in. So for the rule-based row filter, we could say, all right, if and this is similar to the rule engine, right? It's a similar kind of syntax that we saw before. So we're going to say if the arrival delay is greater than this thing I just calculated called my stats, then my little special character, right, equals greater than, then I'm going to call this true. I'm going to say that's an outlier. And what I want to do now with the radio button here is exclude the true matches. So if I have something that matches up with this, I want to get rid of it. It's an outlier. It's way outside the norm. So now when I execute that, I've gone from 3547 rows to 35. So I got rid of 2 rows, probably because that's a really, really wide way of defining what an outlier is. There's probably more outliers than that. And so there's other ways that we could actually look at outliers. This is not, we do this in the example because it's a way to show you the math formula and the rule-based row filter node. This is not how I would actually look for outliers in a data set. Let me show you how I would do it. I would use a box plot as a visualization to first get an idea of what's going on. So let's look at a box plot here. And in fact, we'll just look at a box plot of the arrival delay, not of all this other stuff, although we could. Let's just focus on one thing at a time. So we're going to look at this box plot. I'm going to execute and show you the results. So what if you haven't seen a box plot before, what this is like a common statistical visualization for looking at the distribution of a particular variable in your data set. So here we're looking at only the arrival delay. And what this is showing is this bold line in the middle here with a 3 by it. This is my median value for everything in my data set, all 30,000 rows, whatever it is. My median arrival delay value is 3. This little box here, this is the first quartile, -8, and this is the third quartile, 28. So when I divide my data set up in rank order and look at the quartiles, you know, this is the bottom 25% cutoff, and this is the 75% cutoff. So the middle 50% of my data falls in between these values and is probably, you know, pretty reasonable. We also have what are called these whiskers, which end up being calculated as something called the interquartile range. So the interquartile range is the distance between the first and third quartile, which turns out to be the distance between -8 and 28, which is what, 36, right? So to calculate the whiskers, we take 1.5 times the interquartile range, and then we add that on to the first and third quartile. So now we're looking at something that's, you know, still, when you try and interpret a box plot, you say, well, this is still probably reasonable, but we're getting towards the edge of our distribution, right? So we have here arrival delays of almost an hour early, along with almost an hour late. And anything beyond an hour late is marked with either these circles here, or for really bad stuff, these X's. So these are, and there's a lot of them, these are outliers for arrival delay. So we have a lot of them. Now, that cutoff that we just calculated before for 470 minutes or whatever it was, you can see that there's actually very, very few, as you would expect, planes that arrive 6.5 hours late, because otherwise the airlines would go out of business. So what we were cutting off before with our manual calculation was just like these 2 or 3 guys at the top. We probably would be much more interested in cutting off, you know, around here somewhere and getting rid of all of these guys as outliers. It turns out there's an easy way to do that with a single node in Nime, but I wanted to show you this box plot visualization first, because the node I'm going to show you next uses the box plot as a basis for removing the outliers. So keep this in mind here for a second. I'm just going to minimize it. Let's use the Numeric Outliers node. So for the Numeric Outliers, let's put this up here for a second. If we open up the Numeric Outliers, and again, we'll just look at the arrival delay because we just look at its box plot. What we can do is we can say, all right, I want to get rid of outliers in my arrival delay field. Nime is saying, okay, I'm going to calculate those outliers based on this value k, which is 1.5, which ultimately ends up being 1.5 times the interquartile range, which I just showed you on the box plot, which is to say anything outside the whiskers is going to be considered an outlier. Now, if we find something that's an outlier, what do we do with it? We could look at just the high-end outliers, we could look at just the low-end outliers, or we could look at both. And then when we find them, what do? Do we replace them? Do we just get rid of them entirely? And if we replace them, what do we replace them with? A missing value or the closest permitted value? So there's all sorts of things you could do here. I mean, generally you want to be careful about removing data from your data set. Probably that's not a good idea. But if you're going to do a replacement, you have to be careful too, that you're not somehow introducing additional bias into the data. So there's different things you could choose to do. But, you know, basically by applying this node in the way that we have it here, we're going to replace any of our existing outliers with missing values, where an existing outlier is going to be So long as that value of 1.5 is set, it's going to be anything that shows up beyond this top whisker. We don't actually have any in the below the bottom whisker, although we could, but we don't here, so nothing will be removed from the bottom, but you would be removing all these guys from the top. And the Numeric Outliers node is going to do that for you automatically. It's not going to generate this box plot for you, but that's what it is actually doing. So I think that's worth demonstrating to you. And when you look at the Numeric Outliers node, you get the treated table. Oh, I didn't execute it. So you get the treated table, which is just, this is what happens after I apply my missing values. But you also get the summary of the treatment. So you can see that it went in and it identified, oh, I guess it identified outliers for everything because I didn't configure it the right. Let me hold on just a second. If we're only looking at arrival delay, which I think is a little easier to digest, then if we look at the summary, we can see at a glance, okay, here was the lower bound, here was the upper bound of any outliers, and we found 2,693 observations outside of those bounds. What did it do to those? It changed them to be missing values. Okay. We could have removed them, we could have imputed them. There's other things we could do. So just wanted to kind of go over that with you guys. I'll skip this middle part, which is applying the auto binner and doing some more complicated stuff, because it's just a different way to calculate the outliers manually. But practically speaking, I think it's going to be much more common that you just use the Numeric Outliers node anyway. So having said that, I think I actually did this slightly wrong in that I wasn't supposed to apply, according to the instructions, the Numeric Outliers node to the arrival delay. I'm supposed to apply it to the security delay column and remove those flights. So let me set this up appropriately now to follow the instructions instead of to try and kind of teach you about outliers. So we're using a different column here, not arrival delay, but security delay. And if we fall outside the boundaries, then we're going to remove them, not replace them. Okay, so this is according to what the instructions asked us to do. This would be the result. And then note that we're not really doing anything with number 2 here, but that turns out to not be a big deal. Okay, and then the last thing I wanted to show you, and then, I don't know, we've got 20 minutes left. I probably won't take that long unless you guys just have lots of questions. This last bit for normalization and partitioning. So again, I'll blow this up, make it a little larger. We want to normalize the numeric columns first. So what is normalization? Let's use a normalization node to see what it is. I spelled it wrong. We want to use the normalizer node, and here it is. So use min-max normalization into the range between 0 and 1. So that's the default setup for this guy. And it's going to look, you can see we have all of our integer columns here and then a double column at the bottom. These are all our numerics, and we're basically going to squish them down to between 0 and 1 based on calculations that are done based on the mean and standard deviation of each associated feature here. Why do we care about that? Why do we want to do that? Well, it turns out that for some models, algorithms that you could use, you want your numeric columns to all be of the same scale. If I have, if I want to compare a value between 1 and 10 to a value between 1,000 and 10,000, from a model perspective, since those aren't the same scale, you might end up with some kind of weird stuff going on if you just left them in their original scale. So forcing them all to be between 0 and 1 eliminates the tendency for a model to favor one feature over another when it's doing its predictions just based on how big a number is, basically. That's why we're doing this. There are other options for normalization. You can read about them in the description for the node, like Gaussian, z-score normalization, or decimal scaling, but we're just doing between 0 and 1 here. And so when we execute this node and look at the results, then you should see anything that was a number before is now going to be compressed to be between 0 and 1, assuming it was a number. If it was a string, which some of these still are, things like precipitation and snow depth and things like that, then it's not affected. And practically speaking, I don't know why we're not doing it in this exercise, but I would have gone and converted some of these other things to integers, or not integers, to to numbers using a string to number node, because obviously our metadata doesn't make sense as a string. But setting that aside, normalization is what we just did here. And the last thing that we want to do is to do some partitioning. So remember what we said in the slides, we need a training set and a test set. A training set, which is going to usually be quite a bit larger, that we're going to use to actually create our model, and then a test set to see how well that model performs. Now, because this is time-based data, it's not really time series data, but there's a time element to it, in that we have flights that are occurring on each day, right? What we're going to do is we're going to split the data set up according to days. So we'll say we'll use the first half of the month in January 2007 for our training set, and the latter half of the month is our test set. So that'll be a 50-50 split. Usually for other types of partitioning that you would do, you would use what's called a partitioning node, and you would do a kind of a random draw to do that partitioning. But here we're being explicit, and we're saying the first half of the month versus the last half of the month. And so to do that, we're going to use the date and time-based row filter node. And to do that, I have to be able to put an ampersand in my search. There it is. Okay. So what I can do, I can actually use two of these. Is probably the way to do it. So I'm splitting into two data sets. I can say for this top guy, my training set, we're saying it's going to contain flights from or up to January 15th of 2007. So I'm testing on the column date, which is the only one that I have that is actually of Nime date and time format. My start, I can uncheck this box because I'm going to go from the beginning of my data set, whatever that is, to end on January 15th, 2007. So I could use the little calendar, and I could scroll all the way back if I want to, but this is not usually how I would do it. I would just punch it in, but just to show you that this is here. So we're going to end on January 15th, 2007, inclusive. So now when I look at this guy, after I execute it, I should only see dates in here that are of the first half of the month. So there's my date column. Oops. I lost it. There it is. Yeah, 01 through 015. So perfect. That's my training set. And then down here, I'm going to do something similar, except now I want to start on the 16th. And here I will just punch it in, 2007, 01, 16 inclusive. And so now that should include everything else from that point forward. Something that I didn't mention earlier during the demo, and I can't believe I didn't do this, is when we're dragging in these nodes, it's usually really helpful to label them as we go. So you can see whenever I drag a node in to the canvas here, it's marking at node 1, node 2, node 3. I can double click on this node 2, for example, and I can change this and say, I'm going to call this my training set. And this bottom guy down here, I'm going to double click and call it my test set. And here under normalization, I might say, 0-1 scaling. I want to leave comments to myself all over the place because that's just good practice, right? I want to, if I hand this workflow off to somebody else, have them be able to understand what I've done by reading the workflow. Also, it's just a kind thing to do to your future self. If you have to come back to a workflow after 3 months, which is not uncommon, and you can't remember what you did, having good notations is crucial, right? This is like if you're writing code, you leave comments in the code. This is the same concept. You leave little notes to yourself below each node about what they're doing. And then you also have these annotation boxes. Now, we've been using these to set the directions for you about what's happening in each exercise, but you can add these wherever you want. Like I can draw by right-clicking on the canvas. I can say new workflow annotation. I could draw a box around anything, right? And I can, add some text up here, and I can change the colors of the borders and change the thicknesses and whatever I need to do, right? Because this is, again, this is all about drawing the eye to particular parts of the workflow, highlighting things that are important, explaining what you did. It's a part of what makes Nime a really powerful tool is not only that, drag and drop and not having to write code, but having a visual representation of your workflow that you use to explain your analysis, right? Super important. So That's not really part of this exercise, but since I didn't say it before for some dumb reason, I wanted to make sure I get that in there. Make sure that you get into the habit of labeling your nodes and also adding in annotations where it makes sense to do that. Okay, we're coming up, we're at 2:45 my time. We've got about 10 or 15 minutes left. This is most of what I wanted to show you today. We've gotten to the end here of exercise 1, where now we have a training set and test set that has been cleaned. We can then use this data set to go, into group 2 and start setting up the models, and that's what that whole group is about. This is all being recorded, so if you want to look at the recording for group 2 later, you would basically, when you look, in fact, you can go look at the group 2 exercise, which you're being provided with. If you open that up, you start with this meta node that has all the stuff in it that we just did. And then you go through the process of building the models. So each one of these groups today builds on the preceding group. And if you have time to go later to watch that video and work through those exercises, I would encourage you to do it just to add, some additional knowledge about how KNIME works to your repertoire. Any questions from you guys before we wrap up today? Like I said, I don't really have anything else left, but if you have questions about the exercise or just KNIME generally, what kind of things we support, do we have a node that does X? I'm happy to try and answer any of those for you. If not, that's fine too. Cool. Yeah, Mark's going to sign off because it's late in the UK. No, I understand. Do you have a KNIME sample for data quality? Asks John Michael. Meaning what? Like a workflow that you would do kind of typical data cleaning operations with? Yes, or data checking. So there's a node that will do, it's called the statistics node or the data explorer node. Data explorer node is a little bit nicer. If I use the data explorer node, I can connect this here, execute it, and look at its view. And this is going to tell me all sorts of stuff about the distribution of my current data set, right? So for my numeric fields, I get kind of standard statistical calculations, right? Mean, standard deviation, variance, the second and third moments, if I care about that. Also number of zeros, number of missings, and then I even get a really small histogram so that I can tell whether data is skewed or not. If I have a model that cares about skewness and I need to do some normalization before I feed this data into a model, then I can see that at a glance. I can also look at my nominal columns to see what all the available or potential different nominal fields are. Like you even see for here, this one called tail number. This is the tail number of an aircraft. This has more than 1,000 different nominal values, which makes sense because it's an identifier, right? And so KNIME has highlighted this field for me to show me that there's more than 1,000 of these. This is probably not something you would ever want to include in a predictive model, right? There's just nothing useful there. And then you can look at the data itself in this view as well. So that's the data explorer view. If you just kind of want to start digging into what your data might look like, and then if you get some ideas here, like I want to do a log transformation to get rid of skewness or something, then you can move on to some other different nodes. Can we use it to compare two same files that are generated on a different day? Sure. Yeah, you could load in the data and then there's a table difference checker node, I want to say is what it's called. Yeah, table difference finder, table difference checker, to be able to see if, how dissimilar two different tables are. You could calculate differences between them. Baruch, you're asking, how can we set up working with Python? So the way we generally recommend you to do that is to have Anaconda installed, because we do have a bunch of nodes that use Python on the back end, especially for our deep learning integration. So if you have Anaconda installed already on your system and you go to File Preferences, you can go down into KNIME Python, and we actually have in the options, you can see that I already have like a Python 3 environment set up. that I have several of them set up, one for deep learning, one for the TensorFlow 2. I can select one of my existing environments, and if I don't have one, I can click the create new environment button, and Nime will go off and work together with Anaconda to create an environment that has all the packages that are needed for Nime to interact with Python effectively. Once that takes a few minutes, once that's done, then you can use the existing Python nodes that are within Nime, and there are many, to execute Python scripts to load data from Pandas data frames, to create visualizations in Python, whatever you want to do. Build deep learning networks with Carrots and TensorFlow. So there's a lot of stuff that you can do potentially with Python. We even have the ability to go back and forth between Jupyter notebooks and Nime using a particular Python package. It depends on what you want to do, but we have lots of examples on the hub about how you could use Python. So I would encourage you to search the hub and see what's out there to get started with Python and Nime. There's a bunch of blog posts that we have about it too, because we have folks that are using Python internally.